peek at one of these here. This is a Thermoswitch. Different than a thermistor and a thermocouple. It's a Thermoswitch. Had a couple of these laying around at the place that I'm renting, and I thought we'd take a look at this thing, see how it works, and pop it open and see what's on the inside. I'm assuming it's a switch since it's a Thermoswitch. This thing here says it's a from the Fenwal Corporation. It's rated at 10 amps at 115 volts AC and 5 amps at 230 volts AC. The contacts open on temperature rise, and the temperature range is from negative 100 degrees Fahrenheit to 600 degrees Fahrenheit. Catalog number 17102-0. The different numbers there represents the different temperatures and whatnot. So I was looking at the data sheet for this. It's a pretty interesting device. It is a stainless steel covering here, and apparently this here will expand and lengthen at the different temperatures. Of course, I don't have nothing to make it do that will notice, I'm sure, but I got a pan of water sitting over there. We'll throw it in. We can bring it up to 212 degrees because that's when water boils, so we can check it out and see what it does. But it's pretty simple. Goes in, goes out. This here, this adjustment here is what you turn to set it to different temperatures. It comes from the factory set at around 74 or 75, I think it was, and or you can get them set at something different if you request it. And then these holes here are for a little cap that covers that, so nothing gets down in the threads, no liquid or anything like that, because it's only this part here, well really this part, that gets submerged in any kind of liquid or in a furnace, for instance, and that's from the picture. I should put that up here. The switch is actually right in the center there, so you could see that by the picture and kind of see what's on the inside with the picture. But we'll tear it apart ourselves and take a look inside. But it's pretty basic. I got what I got here, just a 9-volt battery, regular LED, and a 330 ohm resistor, just to give us some feedback on what it's doing. So right now it's set to, it's closed because it's not hot or anything. And let me set that up here. That thing's pretty bright, so we can still see it there. So, but if I turn this little thing here, let's see, clockwise, that adjusts it for going into like the minus 100 degrees. So I can actually turn it to turn that LED off. So now the switch on the inside's open. So if it's on right now and the temperature starts to go colder and colder, then that light should turn off, just like doing it like this. So when we put it in the hot water, since it's connected right now because our light's on, the hot water should stretch this out or stretch it that way. This is a tension device. They also have compression devices, but this particular one happens to be a tension. So the inside there stretches. It's connected to this, so it stretches and pulls those contacts apart when it reaches certain temperatures. So we'll see when we throw it in the water that when we start heating it up, the light's going to go off. So I'll turn it to increase the temperature, and the light will go off, and then this will heat up, the light will come back on. I'm wondering if I'm saying that right or not. Well, let's throw it in the water and see what it does here. And then after we get it done out of the water and everything, then we'll tear it apart and see what's on the inside. So let me go get this set up over on the stove, and we'll tinker around with it as the water heats up. Alright, over at the stove, got our light, our battery, our thermal switch, our stove top is set on high. Doesn't take long for the stove to get to boiling, so we'll hook this right up in there. I got some pliers here to hold this so it doesn't get too hot. Let's connect this. And I know I said that backwards as soon as it come out of my mouth about when this heats up. It says right on there when it heats up, the contacts open on temp rise. So when the temperature goes up, the light goes off. We'll adjust the light to come back on every time it goes off until it reaches 220 degrees or 212 degrees, and then we'll actually have this set at 212 degrees then. So if you ever want to put it in water and boil something and at that temperature, then all you gotta do is throw this in there. But you know, I don't know around home, I don't know how often you would use something like this, but you know, you never know. So this shouldn't take long. Probably, I think it's usually a minute or so, or probably a couple minutes. I don't know. I think one of them, I think the directions on this stove said 90 second boil time or something like that, but I don't believe that. I've never timed it, but I won't say much during this, so I'll kind of speed this up once we get going a little bit, so you don't have to sit here for the whole time and wait for it to heat up. I'll kind of, you know. So right now we're just waiting for the contacts to open, because right now they're closed. Oh, they just opened up. So now I'm going to turn this counterclockwise because I want to increase the temperature. So I just turned it a little bit to turn that light back on. Now it went off again, so I'll turn it again. Let's get this over here somewhere so you can see it. Get my hand out of the way. So you can see the temperature's going up, and I just kind of turn this a little bit. I mean, I can turn it a lot more and then just wait, but I don't want to overturn it, because then I might be waiting here forever and then it never turns off. But the spec sheet says for every full revolution of this screw here, it changes the temperature setting about 100 degrees, I believe it is. So, and these here you shouldn't take them right from hot to right to cold and stuff like that, of course, because you'll damage it from the shock of the temperature change. The pan's got little bubbles in it, but not enough to start boiling yet. Just remember, every time I'm turning it counterclockwise, because that's the way the arrow is pointing on this thing to increase the temperature. The temperature range for what this can be set to. Now most of us know water boils at 212 degrees, so that's about as high as we're going to go on this. So once it gets 212, if I turn this just past the 212, that light should just stay on because it shouldn't get any hotter. And I'm making sure I'm not touching the bottom of the pan. I'm just right above the bottom of the pan, so it's not there's no contact on the pan on this. I only have it resting right here. Getting close. Hopefully the water doesn't boil over the pan. I did fill it a little high. Now we're getting some good bubbling going on now. We're probably about to the end. It's flickering just a little bit. That's my connections. A little bit more. So remember, it's not gonna. This thing's not gonna get any hotter than 212 degrees Fahrenheit. So once that light stays on, which it looks like it's about going to stay on now. So if we were just to nudge this down a tad bit, now we're going to go clockwise to turn it back the other way. Just a tad bit. Just so that light goes off. We can probably say that this thing is set at about 212 degrees. Maybe turn it down a little bit more. And the data sheet says that you shouldn't trust this a one-time setting thing. You need to take this out, let it cool down, put it back in, do it again, you know, on your equipment that you're putting them in to get the true reading. And of course you need a temperature gauge to set this. You can't just do it like this because we don't, let's say we didn't know that water boiled at 212 degrees. Okay, how are we going to tell when it's 212 degrees? We need to put in a temperature gauge to tell us that. So it looks like we're right around there. If I can change that by just lifting it in and out of the water and moving it just a little bit. So that thing, this cools down pretty fast. So turn it back up just a little bit, or oh, I gotta go down, that's right. So if I take this out, it reacts pretty quick to the change in temperature. So it's a pretty interesting device. Alright, well, we played around enough with the water. Let's bring it back over to the bench and see how we can get this thing open. We're back over on the bench. I was looking at this before I went back on camera here, and realized that this is a trickier to get apart than what I thought. When I first looked at this, you know, didn't know anything about it. I thought maybe these little grooves right here, there's a special wrench that you put in there, and then this thing would like unscrew, then you could pull it apart and take this out and pull all the guts out and everything, take this off. But that doesn't work that way. After looking further down on the data sheet, this is actually heliarced at the end, and where this piece goes down to about right here, there people call it heliarc or TIG welding. It's done on both sides like that, so this thing isn't coming out no matter what. So that only led us to do it the destructive way, and that was with the old Dremel tool and a cutoff wheel here. So that's what I did, and I did all this so I could save you the pain and agony of watching me do it, and I have it tore apart. I believe I cut it right here because I thought maybe I would just pull this top part off and then we could see what was going on. I wasn't able to pull that off, so I actually cut these down here first, before I ended up cutting the end of it off, because I thought maybe it was just stuck or something. But that was before I found out that it was heliarced. So I ended up cutting around the top too, and then I was able to pull this off. I had to squeeze this apart to get it off. I just kind of crammed this back in there. Well, we'll just drag it out like this. This here, we got a little film of mica, I think it would be. I thought I seen some silicone stuff like this too, but I think this is mica. And so this is what we got on the inside. This is what it looks like. And the only thing I noticed was this thing moves up and down. And I come to the conclusion that when we're adjusting this screw here, when this thing's heating up or cooling down, whatever way you want to go with it, this is the full distance that this thing is going to stretch to give you adjustment here. So you're only going to be able to adjust this screw as much as this thing will allow it, because this is actually, remember, this is a tension one, so this is, I'm assuming it's pulling it out, and it's pulling on these pieces right here. You can see that they're actually bowed, so the tension that it's pulling it, when it's pulling it, it's actually pulling these pieces straight, which is then pulling them apart, like this to open up that gap for the contacts. So it's just, that's opening and closing it. So that's how that works. And this, like if this was all the way here, I'm thinking that can't see it on this one anymore because I ruined it. These grooves right here on both sides, there's a piece right down inside here. You can see it right there. That V looking piece, that's on both sides, and I'm thinking that those are riding up and down these little slots here as this thing is stretching and compressing. And but let's take this out. Now this had me thinking for a while there, because if we look at this here, this piece here threads into this piece here, okay? Well, this piece here has a threaded rod on the end of it. This piece right here in the center, that threads into this. It threads into this. So I'm thinking, I was confused, and I was like, how was this thing being able to get pulled and stretched when when this is actually holding this piece here. But it had me thinking about this for a while, but yeah, I finally got over it, and I kind of understand it now. So it's I understood it after I realized that this piece gets actually stretched. So okay, let's take this out here. This just holds the wires, and there's a little piece of rope in here or something that they use to help seal this up, to try to keep I'm sure water and moisture and all that kind of stuff. That's all that is. And now we can just pull this straight out. So when we pull this out, these lines right here that I was talking about, this piece right here is what slides up and down on that. So let me just pull this all the way out of here. So now this is the whole piece, and this actually threads on here when it goes through there. So it like holds it in place, so this tube can stretch this thing to straighten out these things, and you adjust the temperature by this. So that's pretty much what's on the inside of that. And it has some pretty good size contacts. They look like about 1/4 of an inch in diameter. And then these, like I said, these little things, these little triangle things here are what slide up and down on this. So this way, this thing, I mean, it's not going to go like this anyway. It's not going to spin like this inside there because it's actually welded to this. But so, and then down inside here, if you look way down here, I don't know if you'll be able to tell that or not, that's where it's welded, is way down at the bottom. That's what I was saying. It's right way down here where it's welded. So I think that's it. That's pretty much the Thermoswitch. Not a whole lot to it, but it's pretty interesting on how they come up with the idea and how to be able to adjust the temperature and for different ranges. And now I wanted to mention to you that I played around with this a couple times, and I measured the diameter of this and the length of this from room temperature to 212 degrees, and there was no noticeable change in those measurements. So, and I'm assuming there should be, since they say this grows and the diameter gets bigger, but I'm guessing that you have to get up to more closer to the 600 degree range before that happens. So let's see, I think that's about it. I don't think there's anything else to add. So there you go. That's a peek inside of a, don't be shocked here, of a Thermoswitch that costs almost $300. So if you look on the internet for this right here, you'll find them anywhere from between like $250 to $300. Most of them I saw was around $290, something like that. And you can get some used ones for less than that, but yeah, that's the price. And so we pretty much trashed a working $300 piece of equipment here just to see what's going on the inside. That's about it. So we'll see you on the next one.